Hey guys, welcome back. We haven't really done any transmission videos on the channel for a while. In particular, we haven't done any live coding or live designing or live anything really for a while. And I think today, on a lazy Friday afternoon, after a pretty intense work week, might be a nice time to do a little bit of that. Before we start though, if you're waiting for the next video on the video playback, video codecs, don't worry, I am working on that. I actually did a little bit of work on that today, but those videos take actually quite a bit of editing and motion graphics and animation and all of that. So it is coming, but takes a while to make those videos. Now, in the meantime, I am, of course, working on the game itself. The game which you can see on the screen, the game called Traction Point. And this week I've been working on something that I haven't actually spoken about, really discussed at all on the channel for ages. And that is particle systems. Now, as you can no doubt see, this is a vehicle game, and as you no doubt know if you've been following the project for a while, it is indeed a vehicle or car game, but there are no particles on the screen currently, which is a little annoying, sad. Vehicle games typically have lots of particles, smoke trails, exhaust smoke, dust, rocks flying around, all kinds of things. And so why don't we have that? Well, if you remember from the previous incarnation of the project, called Project Slide, we do indeed have a particle system support in the game, or in the engine, I should say. And we had some particles in that game, in that version of the game. But the old way, or the current way, of making particles in the basis engine is kind of limited. I'll show you what I mean in a bit. And so I haven't really wanted to do that, to be honest. My thinking has been that I should probably find some third-party tool to do that. I don't want to build all the tools myself, after all. And I did a little bit of research trying to find a good third-party particle editor and runtime, and I found some. I'm not going to really name any names here because I didn't end up using any of them, but I found some, and some of them were actually really good. But for one reason or another, I didn't end up integrating that into the engine, after all. Instead, I decided I can probably build my own, at least start building it now, make it good enough to be used, and then get on with my life, and then make it sort of better as we go. Before we look at any of these things, though, you might see that there's some smoke here in the distance. This is all faked. These are actually just big spheres. We can actually just destroy some of them here. So nothing here is actually really truly particle systems. It's just sort of mock-outs of how I want things to look. And I'm going for a slightly, not very, but a slightly more cartoony art style with Traction Point now than I did with Project Slide. So I might want to build smoke out of spheres like that, for example. But of course it should be nicely sort of animated and moving and everything. Anyway, what do we currently have? So there's this basis particle editor, which allows you to set up particles. There are some problems with this. This is not very powerful. I mean, you can do all kinds of things here, as you can see, but this is really it. It's sort of rigid. You can't really do anything that it's not actually listed here. So you can set like color intensity, blending, opacity, velocities, initial velocity deviations, velocity angle deviations. You can scale things, you can rotate things, and you can set some drags, things like that. That's all well and good. You can see that there's actually no preview in this editor. We can, however, if we go into the asset browser, we can preview things here. So if we look at the particle, we have a few of these particles. If we connect to a running game, we can get a preview here, and you can see like I'll probably need to double click it. Yeah, there you can see particle system previews. Yeah, some of these actually look kind of nice. I think we can take the grid away. I think this bullet hit looks kind of nice, but then this explosion doesn't look very nice at all. Fire looks alright, I guess. And yeah, you can use these two tools together to sort of almost like in real time build. Oh, if we disable the sleeping, you can sort of almost in real time build particle systems out of these two. But like I said, the main problem here is that this is kind of rigid. This is all the things that you'll ever get to mess around with these particle systems. They also don't support meshes, which is something that, as I just mentioned, I might want to use like spheres to build a slightly more cartoony version of smoke, for example. Things like that. So it's kind of limited, and I haven't really wanted to use this. So, what do I want to do instead? Well, I've been building a new thing. The thing is currently called Merlin. And as you can see, it looks almost exactly like the timbre editor. And you even have some like playback buttons and time here. I'm anticipating adding a preview here into this actual editor. I haven't done that yet. But yes, this is pretty much just copy-pasted from timbre, and then I've just removed some things that I don't need, added some things that I do need, and voila, you have the Merlin editor. Okay, so how does this work now? It is a node-based tool, just like timbre, for example, and I'm not very experienced with how other engines do it, but I get the overall feeling that most engines use some sort of VFX graph for setting these things up. And that is how I would like to do things as well. Not because they do it, but because I just kind of feel like it's probably the most powerful way to actually express these things. So if we start building an effect here, we can actually just let's just save this to begin with. We can save it here in the means data, work folder root. We can put it in games and particle systems. Let's create a new folder here. Merlin testing, something like that. And we can call that test 1. Okay. So how do we actually build a particle system with this? Well, first of all, let me remind you, this is like super early days. So you can't do many things yet, but you can do some things. So if we want to add like a particle system to our car, for example, something that moves along with the car and emits particles to the right, for example. You start with this onStart, which is fired when the particle system is started, unsurprisingly. Well, how would you then set up the emissions? And the nice thing here is that you can just use essentially the standard logic and math nodes to do most of the heavy lifting here. So let's say that you want to have like a steady stream of particles, right? We can use a repeat node. We hook this into the start pin, and we set the period to like 0.1. So that means that 10 times per second this pin gets fired. So for example, if we want 10 particles per second to be spawned, we can hook the particle emitting or spawning to this action pin. So let's do just that. We have a new node here called emit particle. And we just hook that up. And here you can select like point. So if this emitter is attached to the vehicle, point would just spawn the particle at the center of the vehicle. You can also set like a sphere here, in which case you get a sphere radius or a box. Well, we can just use point for now. And here in the lifetime, you can set that all the particles live, for example, 1 would be 1 second, but you can make it more interesting than that. We can use a random float, hook that up to there. Minimum is not going to be 1, but let's or 0. Let's make it 1, and max 3, for example. So now every particle that we emit will live between 1 and 3 seconds, and then it will die, will go away. All right, so that's good. Let's save that. What is this purple execution pin here? So, like up to this point, we've had these execution pins that have this almost like an arrow-looking thing. We have the data pins that are either round or square. The square ones can be connected to multiple other pins. The round ones can be connected to one at the most. But I needed to come up with a new concept for Merlin, and that is these execution pins of different types. And here you can see that we have a particle execution that comes out of this emit particle. And that essentially means that when we connect this to something, we are executing whatever comes after this node in the context of this one particle. So, for example, we can't just connect this to, oh well, that's a bool. That's a bad example. You can't just connect this particle to a delay here, because like what would that even mean? What we can do, for example, is set the velocity of that particle. So now we have two of these nodes that have the same type of execution pin. So we emit the particle. That particle conceptually comes out of this pin, and we can now chain together things that we want to do. If we want to debug droid, for example, we could do that there as well. Let's not do that right now, though, but we could. This set particle velocity node, on the other hand, cannot be connected to this start pin, right? Like that doesn't work. It doesn't allow us to do that, because this set particle velocity node expects us to be working in the context of a particle. So if you do this, this node wouldn't know what particle are you talking about. Here, though, it knows, because we have just emitted a particle. So what did we say? We wanted the particles to go to the right of the car. Okay, so we'll be working in local space, and velocity, we could just go like, 100. So we have x, y, and z. A 3D vector here, but again, we can make it a little more interesting, and we can construct that vector somehow. So let's drag in a vector node. We set that to a 3D vector, connect that there, and we'll set this to, I don't know, 30. So now all the particles will get a velocity which is like quite high actually, and to the right in the local space of the vehicle. That's going to be kind of boring, so let's add some randomness to that, and we can do that by doing a random float. And we can not x actually. X is fine as 30, but we can modulate these other two. So minimum could be like -5, and maximum could be 5, or something like that. Maybe that's a little high. Maybe let's make it like 3. And x is always 30. So they always go to more or less to the right. Let's save this in case it crashes, because because very pre-alpha tool. Okay. So let's see what we have. We start, and we start repeating an action 10 times per second. We emit a particle, and we set the particle velocity. Okay. Now we need to somehow make the the node graph aware of the whole particle's whole lifetime. That can be done with an update particle node, and we just plug it in there. And what this does is that it will stay conceptually in this node until the particle dies, goes away, and you can see that then we have like a normal death execution pin here. And to this we could, for example, we could just hook it up to a format print and go like particle died, something like that. If we wanted to, that would sort of spam our output with text though, so let's not do that. But we could, because it's a normal execution pin. We're no longer working within the context of a single particle. We just like back in the normal flow of the effect, if you will. Now the more interesting part here is the update pin, and this will get fired in the context of the particle every time it is updated. So this is where we could, for example, change the velocity of the particle or something like that. Now, as you can see, we don't have many nodes yet because this is, again, super alpha. But I do have a debug draw particle node here. And this is something that will, if we actually want to see the particles on the screen, we want to plug that in there because I don't have any rendering yet. So this will just draw a sphere. You'll see when we get there. And if I haven't done anything stupid, this should actually already sort of work. So we just need to build this. So build effect as a bin Merl effect, binary Merlin effect. That's good. We should get that here in the basis asset server. You can see that file was added. I'm going to drag that up to the side. Okay, so how do we then attach one of these guys to the vehicle? Well, if we go to the code, we have this Merlin effect component. Really quite simple little component. Some commented out code here still. Basically, what we do is we call merlin.load effect, and we give it the path to the file. So that's this guy right here, like the path to the file that we built. That gives us an effect description, and out of the effect description we can then create instances. So on object created, it will simply load the effect description and then create an instance, and it will auto start that instance if we set it to auto start it. So just to do something very simple here, I'm gonna take one of these guys and I'm gonna attach it to the test vehicle. So the test vehicle is the vehicle that we just played around with. And just search for Merlin effect component. Okay, and we get it here. Effect path. Like this probably doesn't. It was called test 1, right? Yeah, it doesn't show up here. Yeah, I need to work on the asset browser a little bit for it to show up. It doesn't actually detect it as a resource yet. But again, early days. Anyway, the effect path is that, and we can set it to auto start, and then we can just save this, and that's fine. So now if we run the game, and we might want to come here and do it. I think I have the correct command line parameters here. You can see, hey, we're actually spawning spawning something, right? And it always goes to the right of the vehicle. What about that? And regardless how we orient or rotate our car, the particles always go to the right, with a little bit of modulation in the Y and Z axis, like we wanted. Like this thing should actually hot update. So if we do this, we can maybe put this to the side there, and then we can just we can take these away. So we always do just the 30, and then we build, we save, we replace, and we go. You can see now when we took that away, it becomes very, very boring. So let's put those back. Okay, So that's kind of interesting, I guess. If you took this local space thing away here, and then did the export, you can see that now it's always going in the world space, along the world space x-axis rather than the local space of the vehicle. So that might be useful in some situations. Okay, that's interesting. What else can we do? Well, the interesting thing with this node graph, which I sort of hinted at already, is the fact that you don't really need to have any sort of particle definitions or something like spawn 50 of this particle type, because you can just do those dynamically. Like if we wanted to have, let's rebuild this so we get back to where we were. So we're in local space. We have these particles now sort of coming out from the right side of the vehicle. What if we wanted another particle type? And it would come out from the left side of the vehicle, and it would come out in sort of bursts, and then the particles would sort of rise, or they would go upwards. How would we do that? And it's remarkably simple actually, because we can simply we can take that and we can copy paste it, put it down here. Let's maximize this for a bit. And we can take a repeat here. And just put it here. And let's say like every 3 seconds we want like a burst of particles coming out this side of the vehicle. We can do like right side on that side, and this would be left side or something like that. Like make it a bit easier to navigate when you get back to this after a while. Right, so left side, every 3 seconds we fire this. Okay, so how do we get, this emits a single particle. How do we get, like a burst of them? Let's say like 20. And for that we can just use a for loop node. So we connect that to there and the body to there. Can move these things down a little bit, and we just do first index 0, last index would be then 119 if you want 20 of them. Right. So every 3 seconds we fire 20 of these guys. We want them in the opposite direction, so let's say minus 30. And the z can be probably the same as we wanted, or as we had before, but we wanted them to sort of rise, go upwards. So we can do something like maybe like max 8, minimum 4, something like that. And then just put this in the correct order to make it a little less messy. Like so. So we negate the x-axis, still working local space. We negate the x-axis so that the effect goes in the other direction, and then I modified the y coordinate to make them rise a little bit. Okay, let's try this. See how it looks like. And now you can see every 3 seconds we get a burst of particles in the other direction, and they sort of go upwards a little bit. We can even drive around here with the camera sort of stuck here to get a sense of the thing. And of course, if we want to, we can just have these go like in world space, for example, something like that. That might be weird looking. So now one of them goes in world space, and the other follows the car. It's a bit of a contrived example, I know, but I hope this sort of demonstrates how powerful these node graphs can be compared to like a static editor like we had before, where you needed to set up these sort of groups of particles and then work within the constraints that the editor gave you. So that's it, basically, a small demonstration of a system that I've been building for the past few days. Now with this there are still obviously a bunch of things that need to be done, like rendering for one. That's a big thing. But it shouldn't be super tricky to actually do. Like meshes, for example. This time around I want to actually use just normal standard materials for the meshes, for the mesh rendering. So I should, in theory, just be able to instantiate meshes and just let them be drawn naturally. The old system only supported particle billboards, and I want those as well. They can be very handy for certain types of particles, and then I can even support more render types. Haven't exactly figured out yet how to hook this into the rendering, but maybe this update particle will have like a pin that allows you to connect some kind of particle renderer to it or something like that, and then that will hook into the whole rendering side. But that remains to be seen. Another thing that we will need to do is we will need to, just like with the timbre events, we will need to expose parameters. So let's say like you have an exhaust smoke particle system that's connected to your car. Well, you would probably want to be able to tell the particle system the RPM of your engine so that it can behave differently based on the throttle, things like that. It's very important. And then, of course, it still remains to be seen how performant this is with lots of instances. Like we can spawn some more of these guys here, and the performance should be good, should remain good. The problem currently is probably that this debug rendering that's used to actually draw these guys now isn't very optimized, so it will probably slow down the game after a while. The actual update of the node graphs is reasonably performant, but I'm sure it'll be an issue sooner or later, and then I'll have to come up with ways to optimize that. But that is not really a problem, and that is probably not going to be a problem, I think, because I won't have that many particle systems after all, and if I do optimize those node graphs, it will benefit lots of systems, because it uses just a very standard so-called sprinter node graph to actually evaluate this node graph and execute it at runtime. Just like Timbre and Nemo uses, so the mission scripting system that I showed you in a previous video. They're all just sprinter node graphs. They work basically exactly the same. So any optimization that I do will benefit them all, and we will be just happier for it. So that's pretty cool. I wonder what actually happens if I delete one of these guys. Yeah, they just go away currently. Okay, well, yeah, lots of things like this that we need to sort of handle. We need to handle them like having their particles sort of naturally die as the particle system owner dies, things like that. But yes, that is it for today. I hope you found this interesting. This has been kind of fun to write, even though I wasn't kind of supposed to do this. Lord knows I have enough tools to debug and fix, and now I have one more. But I still think that this is probably the best solution to my particle problem, given that I already have these node graphs working quite well, and it's pretty easy to add new things, new node types. So that's it. Let me know if you have any questions, suggestions. Feedback is always fun to read. Anyway, I hope to see you in the next video. Have a good one, and bye.